Okay, good morning, welcome to
FamilyMath123b.
23b. So today we're going to do something a little more complicated, so I'm sorry that this might be something, a lot of stuff we haven't talked about, okay? Especially with the square roots. But we're going to try to show why the continued fraction for the square root of 2 equals this. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus dot dot dot.
Yep.
And we're going to do this using a method my high school math teacher taught me called split, flip, and rat. Split, flip,
And rat.
and rat. Okay, are you ready?
Yep.
Okay, so in order to do this, we have to understand a little bit about what the square root of 2 is. And can you tell me what two integers the square root of 2 is in between? You know that.
Yeah, it's gonna be 1 and 2.
Okay, because 1 squared is 1,
Yeah, and
2 squared is 4, so the square root of 2 is in between, and in fact it's equal to, well, approximately equal to about 1.41.
Yeah.
And then, but it keeps going. Dun, dun, dun. So the first thing we do is we split it
And
into the integer part and the not integer part. What's the integer part?
1.
1. And the non-integer part is this, 0.41, everything that comes after the decimal, and that is just simply the square root of 2 minus 1. Okay, now, do you understand why I can write the square root of 2 this way?
Yeah, you pulled the 1 out, and this is the same as the square root of 2 without the 1.
Okay, so square root of 2 minus 1. So I've split it into the integer part and the non-integer part. Now remember, our continued fraction always had integers on every level, right? Now we flip. So we say this equals 1 plus 1 over the square root of 2 minus 1. Does that look kind of strange?
Well, we can do this because it's the reciprocal of this.
Uh-huh.
And
Yeah, go ahead.
dividing by reciprocals is the same as multiplying by the actual number.
Okay, that's exactly right. This is, all we're doing here is saying something like 4 equals 1 over 1/4. Is that true?
Yeah, it's true.
Yeah. 1 divided by 1/4 is 4. The square root is in the exact same way. The square root of 2 minus 1 equals 1 divided by 1 over the square root of 2 minus 1. That's the flip part. Okay, now are you ready for the rat part?
Alright.
Yep.
Rat. Rat stands for rationalize. Okay, we don't like this number 1 over the square root of 2 minus 1. It's a number that has a square root on the bottom, and people just don't like those things.
No.
I don't really know why, actually, but for continued fractions, you definitely don't want this. So we need to get rid of the square root on the bottom. Do you remember how we do that?
But the square root of 2, you can split into this again.
Oh yeah, absolutely. And we're going to go through this a couple times, but right now we want to focus on this thing that's on the bottom, 1 over the square root of 2 minus 1. And we want to rationalize this. In other words, for this fraction here, for this fraction, we want to get rid of the square roots in the denominator. Do you remember how to do that?
You multiply by the square root of 2 plus 1 over the square root of 2 plus 1.
And that's called rationalizing the denominator. Okay?
Because you get a difference of squares here.
A difference of?
Squares.
A difference of?
Squares.
Yeah, remember that movie?
Yeah.
That was funny. Okay, so on the top we get square root of 2 plus 1, and on the bottom we get a difference of squares. And when you square square root of 2, you get 2 minus 1. So on the bottom we get 1. Okay, so believe it or not, 1 over the square root of 2 minus 1 is just equal to the square root of 2 plus 1. That's pretty amazing, right? That's the part that I think is a little tricky for you to understand, but I can say that this is equal to the square root of 2 plus 1 now.
And then we can just keep doing the same thing.
Okay? Now we split, flip, and wrap again. What is the square root of 2 plus 1 going to be approximately as a number?
Well, it's probably gonna be 2.41.
Very high five. Very good. The square root of 2 plus 1 all I have to do is just add a 1 up here. 1 plus the square root of 2 is 2.41. So what's the integer part?
It's 2.
2 plus, what's left after I take that 2 out?
The square root of 2 minus 1.
The square root of 2 minus 1.
And then we're just going to go in a loop.
And what happened with the square root of 2 minus 1, it turned out that when we flipped, we got 1 over the square root of 2 minus 1 which turned into, oh sorry, 1 over that. That's the flip. Which turned into 1 over the square root of 2 plus 1. Which turned into 2 plus the square root of 2 minus 1. And you can see that this process is going to go on forever.
It's going to go down the line.
We're going to get 1, 2, 2, 2, 2, 2, 2, 2, 2.
Yeah.
How cool is that?
Yeah, but it goes on for infinity.
It goes on forever, and you can use that actually to prove that the square root of 2 is irrational,
Yeah.
by the way. But that's it for a different time. But this is how we construct our continued fraction.
Yeah.
And because on this one, which happens to be very simple, we keep getting exactly the same thing over and over again. We know this process will just go on forever and never stop. And that will give us the continued fraction for the square root of 2. That is pretty cool, right?
Yeah.
Split, flip, and
Rat.
and that allows you to find the continued fraction for let's limit it a little bit. Anything of the form like a plus b times the square root of c. And you can even do it by hand. It applies even more broadly than this, but this certainly shows that we can do it for this. Pretty neat, right?
Yeah.
All right, guys, high five, high five. I think that'll be the end of our little detour into continued fractions, okay?
Yep.
Right.
Until later.
Yep.
Maybe when you're 10. Good job. Good job, guys.